All right, so if you've not done one of these sessions before, this is the Ask Walter and Andrei Anything session. So here's an example here. Walter, we're going to get this out of the way straight up. What's your favorite color?
And for the weather report.
Well, obviously it's red because D-Man is red. Now.
That was a serious question.
Yeah, I know. But also you can tell that Andrei and I have been working together for a while because we're sitting kind of, there's a seat
very
between
intimate.
us.
Yes.
You're also wearing completely opposite colors, I've noticed.
Oh, yeah.
All right, so outside of the color question, let's kick it off with something a bit more meaty before we throw it out to the audience. So what would you guys say are the top 3 issues in the D language and the D in general right now?
All right, I'm going to stick to technical stuff, not social issues. I'm not really good with social issues. One thing I think is important for us is things that are blocking industrial use of the compiler. Those are very important because not that a personal user cares about an industrial user, but the industrial user provides momentum and interest and all that, which can really help drive D forward. So we have to return that by supporting them and supporting them better. The number 2 issue is ref counting, and Razvan's effort to get copy constructors in was a major boost to that effort because copy constructors are really necessary to do ref counting correctly. And the third major issue for me is making the implementation of the compiler and the runtime library a much nicer piece of code than it is, because making it nicer will make it much easier to understand and modify and be something that we can be proud of, saying, look, D is enabling us to write really high quality code. And this kind of goes back to what I remarked earlier, is we really want to raise the bar on the quality of contributions to DMD, because we don't want to add more things that we know is not up to our best standards and have to fix it again later. So we really want to start with new things being high quality, and there's a pull request on dlang/DMD where I sort of listed a few items that need to be done in general to improve the quality of the front-end source code.
Cool.
Nothing to add?
That's it.
So this is really like multi-dimensional chess. So I have like really like 3 times n answers to this, right? In the technical realm, I'm thinking number 1 is we gotta get reference counting working perfectly. And by that I mean, because obviously it works today, except impure functions, except with immutable stuff, except this and that and whatnot, right? And all that nonsense. So I don't think it's acceptable that we punt on the issue. I don't think it's entirely understood just how important this is. When you talk about it, it's obvious, but nobody's working on it. So obviously, we, Walter and I collectively, have failed to convince people that this is, it's pretty much a survival matter. We gotta have reference counting working at least better than all other languages. You feel me? Right? At least better than everybody else, right? And there are simple requirements. I mean, it's kind of funny that I need to stress the point. The fact that there's discussion about it. There's this one-liner which says, if you're arguing, you're losing. I shouldn't be arguing about this because I'm losing the argument I'm making. So reference counting is overwhelmingly important. And there are people who are like, you know what, you don't use it with immutable. And Timon, by the way, our major kind of theory person, major contributor to the language, he let me know he can't make it to this conference. He had just some bureaucratic nonsense to deal with. But he's not here. He's not missing the conference in protest. It's an important detail. However, Timon and myself and Răzvan and Edward and Walter were kind of looking at this and working on it on different angles, and we do not have at the moment 100% perfect solution to reference counting when you bring immutability and purity into the mix. And safety, of course. So it's easy to make one that has a subset of the features, but for example, Timon's like, well, with immutable, I'm okay with not using reference counting. And simply that, I understand that from a sort of theoretical standpoint, like, well, if it's immutable, you're not supposed to modify that thing because it's immutable. On the other hand, we got to do it. So sort of the academic response may be different from the response that we need to put forward in the field. So number one is reference counting. I think we gotta have something there. Number two, in the technical, again, this is multi-D chess. Okay, so again, sticking to the technical aspect. Number two is number two is shared. And there are any number of things I could say about that. But I'll stick to the following. Walter is not an expert in like kind of heavy-duty multi-thread programming. He has the basics, as do I. I think I'm like maybe like a notch of competence above with respect to this particular issue of multi-threading, but I'm not an expert in things like memory models and what relaxation means on different architectures and that kind of stuff. So I'm not an expert. So we're not the guys to actually come with a complete solution to shared. And I think we need somebody to actually come with a complete. We need somebody to take shared. Adopt it, make the paperwork, and submit a dip. And we need some. And the fact that we're kind of fighting these nonsensical little technical issues when shared is like they're like the goddamn pink elephant in the room, and it's just sitting there, and we're like, oh, in that corner of the room there's a little dust, and we kind of fight who's supposed to clean up that dust. And there's the elephant, who's, by the way, is pooping and is making a lot more mess than that little speck of dust. So I think this is the second problem. The third, which is in a way kind of comprising the two, is I'm actually surprised that Seb put this great surveys on the board, and one was the quality of the specification, the D language specification. That should have been like -1, okay? -1 out of 5. Okay, I'm gonna not hear you. I'm gonna hear you. So I'm gonna hear the guy who agrees with me. I believe that the specification of a programming language needs to be ultimate, formal, uninterpretable. And one great thing about the C++ language is that they have specified everything ever happened in that language. Like, it's even though it's the fact that it came extremely complicated, it's because they specify everything that's going on, even stuff that was, kind of underspecified historically, and it was like a number of mistakes. I'm not going to kind of get into the exegesis of C++, but a good lesson we need to take from them is they have this awesome quality. They specify everything, and any piece of code you write, you can consult the specification and see what it's able to do. And we don't have that. And we have a vague specification, and on top of vague, you can't build on a vague specification. It's like building the mythical castle in Spain. You know the saying? This is Europe. Everybody should know this. Building castle in Spain, it was because there are so many wars. You build a castle, and the next week there's going to be a war around, and some cannon is going to blow the freaking castle. It's going to destroy it, so you're going to build again. So you can't build on that environment. You can't build on the specification a good dip. And to sort of start the cycle, you gotta first crank the specification up, because then dips come and they build on a good specification. So these are the top three issues I think we should look at. And by looking at, I mean, again, like total ownership. Like there's got to be a shared guy. There's got to be a guy who legally changes their name to shared with capital S, okay? Not even lowercase s, so it counts blue in the code editor, okay? John shared. I want John shared. Oh, okay, yeah. Call your friend. Call your friend. You never know.
Yeah, I mean, we've got definite cases in gaming for reference counting and shared at the moment. So.
Right. So I have like, maybe 9 more answers to different other dimensions, but I think we're talking too much, and I think people should talk more.
Well, can I interject something?
This is an Ask Andrei and Walter or anything, and I've asked the first 2 questions now. But before we go any further...
No. I'll do that later. But I just want to interject here that the reason we started the Human Resource Fund recently was precisely this kind of thing. Whomever Mr. or Mrs. Shared will be, they're probably by definition not going to be motivated to just jump in and solve our shared problem. So if you can donate to the Human Resource Fund, that money will be guaranteed to go to these kinds of problems in the future when we have people to solve them for us. So,
awesome.
All right, let's take an audience question here, and then I've got a question from Discord lined up. So who has a question right here?
I'm coming at this from the background of someone who does a lot of Java development, and performance matters as a way of reducing cost in the cloud. And there's a lot of competing languages out there. Some people look at Rust, they look at its high performance and memory safety. Some people look at Go because they want a simple feature set and they don't want some junior engineer to mess things up. So having a well-defined, well-working language is important. In my opinion, I think the area where D can shine the most is because it has chosen to have a very broad feature set. It can incorporate libraries from other languages extremely easily. It pretty much has every feature that almost every other language has. However, one thing that stands in the way of this is the behavior of libraries. As a simple example, the containers. So if you want a simple hash map or a set or something like that, you have to convert your code into ranges, which isn't always possible. How do you feel about the idea of, even if March deprecated, having an iterator-based support in the standard containers to make it faster and easier to port libraries from other languages? Because I think this is something where D can do that other languages cannot.
So you're saying that the current algorithms and support is all for ranges, but the ranges don't fit the design patterns used in other languages? That's a very good question. I've never thought about that. I can't really give you a good answer about how difficult that would be or how effective it would be.
So as a brief example, I was converting a bunch of C++ code and I ran into this problem. So I just implemented a B tree that could do ranges and iterators. And so I can quickly migrate the code, but then choose when to backport and fill it up. But the fact that the function calls exist gives me that option. Whereas that's why I had to make my own function, because when an option's not there, you basically have to re-implement everything, and most people just pick another language before that. So I kind of want your thoughts on that.
Well, we don't want them picking another language, so.
One quick thing I can add to this is that maybe you should look at Mirror, because it's specifically made by Ilya for this use case coming from C++. And because another reason it also uses iterators is because ranges add a lot of overhead at compilation time. So a lot of benchmarks where you can do that using ranges cost you like 20 or 30% code over an iterator version or the naive for each loop. So if you're looking more in the C++ iterators kind of thing, the mere approach, I guess, would be the one you're looking for. But I'm not sure whether Andrei would favor that for Phobos.
Well, I think we have a false choice on our hands here. So, we have code.dlang.org, and we have dub, and we have a growing, but budging ecosystem of independent code. Historically, we've accepted in the standard library things too quickly and too easily, and we've been paying the price ever since. I think a change of tack would be beneficial for the language and for everybody using it if we went with, well, we're going to adopt into the standard library things that have been in dub and very successful for a while. And I think that's entirely reasonable to ask. How about the dub library to start with, and then we go from there. And there's nobody and nothing stopping people from putting a good library such as Mir itself into dub. Having iterator support in the standard is not a prerequisite to having iterator support available in the D language. And I think this should be the default stance of ours going forward. Is like, well, there's this great. I think the things that should pop up at the top would be, there's been this awesome library in dub for years, hugely successful, tested and tried, fantastic. Everybody loves it. How about we migrate it into the standard library? So that would be the normal path. As opposed to, how about we try this just to please everybody, just to, let's try this out, incorporate in yet another thing that, by the way, you and Walter are going to be the maintainers forever and a bit more, right? So maybe that's, the real question. Should we put things into dub that we want to ultimately get into a standard library?
Cool. Is that a comment to this?
Yeah, so basically Boost, but without the gate of entry.
Right, so Boost is a good inspirational example. It's sort of the de facto kindergarten of C++ libraries that are to graduate within the C++ standard library. And I think it's been immensely successful. And, again, we want to do good things and successful things. And there's no reason, if we compete with C++ if we want to do better things than C++, that's no reason to not take the very good things that they are doing already.
Cool. All right, so this is a question from Discord, somebody calling themselves Dennis. It is a question regarding the quality of the DMD codebase. Walter has expressed that large refactorings to the DMD codebase are generally too disruptive, but is there any plan, short or long term, to improve the source structure of the front end? Currently it is 120D files in one directory. This has a thumbs up, so somebody else is also interested in this.
Mm-hmm. This is a very fairly controversial issue. I'm generally not in favor of breaking everything up into subdirectories and packaging and packages, and other people are. I don't see that that's really going to improve anything. Fundamentally, the code needs to be encapsulated better, and just dividing it up into packages, sort of, in my not so humble opinion, just sort of paints a veneer over problems instead of actually solving the problems. And I think that we should be actually solving the problems. For example, when I implemented DIP 1000, which is the escape analysis on lifetimes, the original code for that had the gather information and act on that information all mixed up together. It would modify data structures, it would issue error messages, it would do all kinds of things all in one walk of the tree. And before I implemented DIP 1000, I decided I wanted to separate the information gathering code from the do some sort of action on it code. And so I split that up, and it took a fair amount of work, and it completely rewrote the thing. But the result was I had one set of code that would go through the AST and figure things out. It would calculate the lifetimes and all that. And then and what escapes and all that stuff. And then other pieces of code that would look at that information and issue error messages, would do the attribute inference and all those things as a completely separate thing. And that turned out to be kind of a life-saving or project-saving refactoring, because although the diff 1000 is a simple idea, D is a complex language, so there was a lot of odd cases going on in there, and by having all this functionality mixed up together, it became nearly impossible to reason about how it should work. But by splitting it up like that, it became a lot easier to reason with, and I had a lot fewer problems getting it to work. What I'm trying to say was that kind of refactoring is immensely helpful. Just simply making packages out of things would accomplish nothing with that. It's just, you're just, painting a new name over the things and calling it encapsulated, and that's not how things should be. I've been looking at a function, there's another function, a rather long one in DMD, that looks to see, does the flow of control fall out the bottom of this statement or not? And it's a fairly complex piece of code because there's a lot of different kinds of statements in D, and each one has to be handled specially. And the code that does it not only does that, it issues error messages for unreachable code. So you can see where I'm going with this. Why does this one piece of code performing two functions? And so far I haven't found a good way to split it up into two separate things. One that gathers information and the other that issues errors, but that kind of needs to be done, and it would significantly improve the clarity and reusability of the code. So, but putting it in a package accomplishes nothing. So I'm not really a big fan of painting veneers over things and pretending things are encapsulated when they're not. It just seems to me like it's avoiding the hard work and the work that really needs to be done. So
Cool.
That's that.
Cool. All right, well, Manu's got a question here first.
Yeah, it's safe to say I feel personally touched by both of your answers to the opening question. I think we could probably...
In a good way or in a bad way?
In a good way.
Just making sure.
Yet to be determined, right? They're all important issues. We could probably start a whole bunch of conversations, but let's pick on ref counting. You said that we should beat everyone else. But our strategy for ref counting, we've just introduced copy constructors, and that seems to be what we want to lean on to do ref counting.
That's right.
Which means our solution starts to look pretty much just like the C++ solution. Now, that's kind of okay. C++'s solution, I would say, is fine, but not particularly satisfying. What are we going to do that destroys C++? How are we going to improve on that?
Single-threaded reference counting for single-threaded objects, friend.
Ah, yeah.
No, it's,
Yeah, okay.
this is it. I mean, D has richer type information available for mutable objects that seem to be single-threaded, and therefore you can do single-thread reference counting statically. You can decide to do that statically. That said, it's with immutable, it's going to be multi-thread because immutable objects are shared by default, and with const objects, this is where the difficulty kicks in. With const objects, you don't know. So you're going to do something conservative or you're going to make a decision. So we're working on that. I think the harder problems are pure and immutable.
There's another aspect to that where we can improve on C++. Often, to avoid expensively fiddling with reference count, you want to return a reference to an interior piece of data in the reference counted object without necessarily incrementing or decrementing the reference count. And the risk there is the lifetime of that reference exceeds the lifetime of the object. So that's where kind of DIP 1000 comes in there, is it gives you a way to restrict the lifetime of what you're referring to in a way that doesn't exceed the lifetime of the reference count object. And my understanding with C++ is that's just kind of a best practice, that you don't exceed the lifetime, but in D we can find a way using the lifetime stuff to ensure that it doesn't, the lifetime doesn't get away from the programmer. Basically, it provides a way to mechanically audit that, and I think that that is an underappreciated key advantage.
And if I might add a related follow-up, I was originally encouraged by the op-inc, op-dec operator pair because that allowed us to collect and aggregate multiple incs and decs and perform them less often, and also elide unnecessary increments and decrements, which is very hard to do in C++ using copy constructors. Why did we move away from that strategy?
Because we couldn't figure out a way to make it work. Rather bluntly, there has been a lot of discussion on that, and a lot of ways we went down that all seemed very attractive, and then we'd wind up into this dead end that we couldn't get out of, and it's went on multiple times, and we finally just kind of threw in the towel on it. I could not make it work in a reliable, guaranteed way, and we weren't willing to compromise and just say, we're just going to rely on the programmer doing the right thing with this. We wanted a way to guarantee it and couldn't find a way to do it, so we kind of gave up on that approach. Not that we really didn't want to give up on it, which is why we spent so much time on it. But we kind of felt that we couldn't find a solution. It was time to move on and adopt something that we know is going to work.
So recently we tried to throw and catch exception in Better C. Is there a plan for classes in Better C?
Well, the trite answer to that is C doesn't have exceptions, so why do exceptions in Better C? Nevertheless, C in the real world does handle exceptions, and well, we don't have a plan for that at the moment. Mainly because implementing exceptions is very difficult and varies dramatically from platform to platform, and is essentially a lot of work. But the Better C, which I've pushed for a while, several people have come up to me privately, including at this conference, saying that Better C has been a big success and an enabler for them. So I'm really pleased about that. Also, Better C has enabled the back end of DMD to be converted to D and a bunch of other stuff. So, and I'm glad to see that you're asking for stuff in Better C, because to me that shows that it's a success and it's a valuable thing that we've done. So that's all good, but there's no current plan at the moment or priority for supporting exceptions in it.
Okay, yeah. When I'm listening to various problems that you mentioned, a lot of them seems to revolve around the fact that there is no control flow or data flow analysis in DMD, or very little of it. And every time this is needed, there is like some custom piece of code that is created that is like special purpose for whatever this is doing. So you were mentioning the piece of code that tried to see if something is reachable or not, and warn or makes, spout errors about it. And there's also the whole lifetime business that is very, very similar. And to me, I don't know. So on one side, I see you raising this kind of problem. On the other side, when the question of introducing an actual control flow analysis pass within DMD, you seem to be very reluctant to do it. So I'd like to maybe hear some of your thoughts on the matter.
What am I reluctant to do?
Introducing like a step to do either data flow or control flow analysis. In
Oh, why am I not doing a more advanced data flow in the compiler?
Yeah, because you end up doing like many smaller version of it that are not very good individually.
One of the problems with data flow analysis is how far do you go with it? And there's no real boundary to it. So what happens is that if you have the compiler behavior dependent on the quality of the data flow analysis, then you have a specification problem saying, is this a valid program or not? You have it compiling with one compiler and you have it not compiling with another compiler. For a simple example, just how far do you go with constant folding? Right now we guarantee that if you have two enums, and they're both integers, and you go one plus the other, it's going to constant fold. Well, let's say one of them is a variable, but you can determine by an advanced data flow analysis that the compiler always knows it's always the same value at that point. Should you constant fold it or should you not? But the problem is the answer depends on how far the data flow analysis has gone. That's not a problem for the optimizer because it still produces a running program whichever way you go. It just may be run faster if it does more data flow analysis. But when your front-end semantics depend on the data flow analysis, then you've got a specification problem. Should the spec really start specifying how good the data flow analysis is? So you see where there's kind of a problem there with that, and I don't know of an answer to that other than minutely specifying how the data flow analysis works in the spec. Now we've done that because the constructors do a primitive form of data flow analysis, and so does control flow drop off the end of a statement or not, and that's fairly straightforward to specify, and that's really kind of where we stopped with that, as we have stopped with how far does the constant folding go.
But by the way, anybody knows Java constructors do sort of a very similar, if not the same, basic.
We do better than
data flow. Okay. So does anyone know what the Java constructors do? How much data flow analysis they do? I'm not in the community, but I remember the research papers from way back when, and essentially it was very basic, pretty much as much as we do. And then there's I think it was a utility ESC Java with an escape analysis, which would kind of detect bugs and kind of more advanced issues. But that was a tool, it was not part of the compiler. It's not part of the language specification. I think that envelope needs not be pushed a lot farther.
I remember now just how far it went. Maybe Java's improved since I read the spec on it, but their data flow analysis for constructors ends at the first control flow construct. Okay, like the first if.
So that's
and these will actually follow
the
ifs and switch statements, and these quits when it sees a loop.
Not loops.
That's the end of it.
How about your favorite, Walter, go-to?
It quits when it sees a go-to, because go-tos you can create loops out of.
Of course.
And it says go-to. Well, it might be it doesn't check to see if it's a back jump or a forward jump. So
just gives up.
But anyhow, you can see there is an improvement to the data flow analysis, but it's easy to specify. It's saying, it'll follow the branches of an if, but as soon as it sees something that looks like a loop, it goes, I quit. Doesn't do any more data flow analysis. But it's further than Java gets with it.
Yes, please.
Stefan.
Yeah, it looks like Stefan.
Yeah, it's actually also about data flow analysis. So the thing is, we do not have to specify how far it goes. We just want to merge the existing things that leverage data flow analysis inside the compiler, so you do not need to rewrite that stuff from scratch and with different sets of bugs every time.
I guess I didn't understand that.
We can take this offline if it's more complicated.
All right. Anybody else have a question? Yes, here we go.
So as I already mentioned, I'm also stealing from JavaScript. And recently I have been using the TypeScript compiler quite a bit. And the awesome feature that thing has, it's basically the compiler is a daemon. So it stores all the files and all the dependencies in those files in memory. And when I then sort of save a file, it just recompiles the things it actually needs to recompile. And that pushes down the compile time to like usually sub-seconds. And the GraphQL backend I have for the app I have takes about 8 seconds to compile. And if I look at the files it touches, even though I made sure that the dependencies inside the project are somewhat limited on each other, it still takes forever and basically touches all the files every time, even though I only sort of changed one unit test line. And sort of my hope would be that eventually we end up in a similar situation as TypeScript, for instance, right now is, where the compiler is just a daemon sitting in the backend. And when we save a file, only the changes that actually need to be recompiled are recompiled. And that also would allow us to use the daemon as also the completion daemon for the IDEs we're using. And like, what are your thoughts on that?
Well, back in the 90s, I implemented precompiled headers for the C++ compiler. And the idea being that you didn't need to keep reparsing the header files over and over again, you could just load them off of disk. So I thought, well, with D, we're going to do the same thing. You're going to take a module and you're going to precompile it, and then you don't have to compile it again. Well, it turns out that in D, because it didn't have all those dependencies on it, it turns out that parsing D code is really fast. And if you store your precompiled module on disk, it means you have to serialize it, write it to the disk, and then when you read it back in, you have to deserialize it. And when you work through what it's going to take to deserialize it, it's actually just as fast to reparse the source code.
I think it was different. The question was, the question was if you like having a compiler resident in memory, having all the data structures there.
Exactly. Okay. Well, then.
Yeah, like RAM disks or whatever.
It's equivalent. It's the same thing, basically. The question is just if it's serialized or deserialized. Which should be free, effectively. Sorry, I think that comes down to the same thing, basically.
You know, it's sort of, then the compiler is no longer a batch thing, which is kind of a
exactly.
re-architecture
That's the whole point. Like the batch thing, I mean, by now we pretty much have unlimited memory.
All right.
Well, we are overflowing memory, and if you kept it all memory resident,
but
then
that is sort of
you have no room for
because
anything
of
else
other purposes, right? But like I sort of don't see any technical hurdles of having the compiler, as Andrew said, having a daemon, no serialization, storing the AST and all the analysis done so far in memory, and then if stuff changes, actually change the stuff that has changed. Like if you stop the daemon, you don't reload from memory something or from disk that was serialized. Just store the raw AST in memory.
Okay, I've written a JavaScript compiler, and I can tell you that D is vastly more complicated. And that means that your dependency information has to be correct. You can't handle any bugs in a dependency if you're going to rely on this, because if you do have bugs in it, people are just going to hit the recompile everything button every time, which is what they do when the dependency information is unreliable. And it's a lot easier to get dependency information correct with JavaScript than with D. So you're talking also about a major effort in annotating the ASTs to say what they're dependent on, and I'm not sure how big an effort that would be, or how reliable it will be, or how to verify that it actually is reliable. So I'm not saying impossible, I'm saying it's a significant challenge to get something like that to work.
Like, I didn't say the DConf 2020, I was just sort of like one of those pipe dreams they have at 2 in the morning.
All right, well, it's good to discuss that kind of thing.
Yeah. It sounds like Google Decade of Code project.
Sort of going in the same direction, I acknowledge that D is extremely fast to pass, but I think the major shift that may come in is in that if you're looking at a project that really takes advantage of the capabilities of the language, then a lot of the AST that actually gets compiled is going to be generated, and it's going to be generated by potentially expensive template instantiations and expensive CTF evaluations, and I think caching after that stage could be very beneficial.
Yeah, agreed.
It could be. I tried caching them in C++, and it was difficult, and it was time-consuming to implement and risky as far as bugs go, because you can have very subtle bugs that you don't notice for a long time that generates corrupt things, and I just try to avoid doing relying on things like that.
But then, right, so maybe like, because, Ethan asked about the top 3 things important to D right now. Maybe the fourth, which got unmentioned so far, would be indeed, we have these advanced features, but there's friction in using them because, for example, computation gets very slow, so you have these awesome faster than the fastest in the world regular expressions. However, a complex regular expression becomes slow to build. So a way to be able to cache the instantiation of a regular expression, or 2 or 10, would be beneficial for any build system. That would be an important method to do, because once you have that, you can afford to take the next step in doing things. And I think experience has shown, not only in this language, but in all programming languages there are, that as soon as you get you get a barrier removed, a friction removed, something made easier, people immediately got to the next dimension of using it, and I think that would be beneficial for us as well.
Back when I first implemented the data flow analysis optimizer, I read a lot about it, and how it works is the compiler generates data flow analysis information, which is where every variable is used and where it's set. And it's expensive computation-wise to compute all that stuff. And so then the compiler would do a transformation based on that, and then it would update the data flow analysis data. And I was reading that the #1 bug was making mistakes in updating the thing. It's where a lot of the effort in debugging the compiler went, is trying to correctly update the data flow analysis, and that turns out to be a very non-trivial problem. And so the data flow analysis thing I wrote, just simply, it throws away the data flow analysis results and recomputes it when it alters the AST, and that has proven to be the right decision, because I've had very few terrible problems like relative to what other optimizer implementers have had, because I didn't try to do that and update it in place. Cool. I concentrated instead on trying to make the data flow analysis data gathering fast, instead of trying to patch it in memory.
Well, mutation is bad, So that's what functional people say.
So that's the pragmatic engineer in me saying, well, this is a hard problem. We'll do it another way and completely avoid the problem.
Cool.
All right, we've still got time for a couple of questions. Anyone?
Historically, we had too many, so I was like, yes, please.
Here we go.
I just wanted to ask where on the priority list speeding up the garbage collector fits in, because there's some extreme problems on both ends. Some problems, like batch jobs, don't really care at all. Email, like in your first lecture today about Thunderbird, had some sensitivity, and then games are like very sensitive. But basically, the faster the garbage collector becomes, the bigger set of problems can be solved, or basically the easiest thing to do also becomes very performant and good enough. It has some big possible advantages of done this. So where does this kind of fit in? I know you guys have more than enough work to last decades, so I just kind of wanted to get your feeling on that.
Well, a lot of people have been working on the D's garbage collector for 10 years and have made incremental improvements to it, and that's kind of where it is at the moment. It seems rather to be resistant to fundamental changes.
We do have
The Symmetry Automotive Code project,
yeah,
the second place.
that should be mentioned.
Yes.
Yeah.
Well, I will do a lightning talk on improvements over the last couple of months that I made, and some other people have some quite okay-ish results, especially the next release will have parallel marking, which improves the mark phase quite a bit. So there is some improvement in that area that make it almost usable in interactive applications with large memory also. It's not as other languages have wide barriers, but I think it gets into the very usable state right now.
Rainer, you may want to mention the work on making it more precise.
What's also merged in one of the last releases is that collector can now be used with precise heap scanning. And on Windows, we also have precise scanning of data and TLS sections. And that's something like what Walter mentioned this morning, that the program doesn't, with a precise scanner, it doesn't no longer accumulate data due to false pointers. So.
And
the symmetry out of Francesco Mecca, he ported Leandro Lucarella's D1 forking GC to D2, and he'll be giving us a blog post about it after DConf. I've already got it from him.
Francesco, can you say a few words right now about it?
Thank you. Hi all. So for the symmetry out of NOV code, I've been porting the Sociomantic GC to D2. We've got good results. The collector is about 10 times faster than the parallel.
That's awesome.
Yeah, the only problem is the high memory consumption and the fact that basically the Gc is POSIX only. So I've been exchanging a lot of mails with Leandro because we don't know if the effort of incorporating such changes in the runtime for such specific use cases makes it worth. Some weeks ago, I don't remember, Andrei talked about having a more modular runtime, and I think that the possibility of incorporating custom garbage collectors would allow people like me that wrote a garbage collector for specific use cases more viable than incorporating changes to the runtime. Okay, that would also overcome the fact that we have this very specific implementation of a garbage collector, and we could work on, I don't know, thread local garbage collector, or incorporating the Bohem garbage collector that has a good performance because it has been improved for like 20 years into the D runtime. But right now, I'm discussing this possibility with Leandro.
Okay.
That's
Good.
it.
All right. I think this will be the last question or statement.
Another statement on that. We have good news for you. We have, in one of the last releases, we also have an open Gc registry added, so you can add your own garbage collector and select it instead of the predefined ones.
I think there's been fair and steady progress on the garbage collector in the recent months, and it seems to me, and please correct me if I'm wrong, everybody. It seems to me that the quality of the GC is less of a gating factor than it used to be. I'm telling this simply by judging like how many posts do we get historically versus like now. There's been a decreasing gradient of posts like entitled things like your GC is crap, and I hate the GC, and I can't get work done, and all that stuff, which was very frequent in the years past. And with a growing community, there's been less of a voice, less of a tenor in the community that the GC is stopping people from doing what they want to do. It's more of a gating factor, the existence of the GC. So you got this in this uncanny valley where it's sort of a bimodal decision for people like, oh, what language is that? D, huh, interesting. GC, okay, bye. And looking at the door right now, I'm just, I'm on my way. I'm leaving as soon as I hear that there is a GC. So the quality of the GC doesn't even factor in the decision anymore. And that's why I believe reference counting is a prime factor for us. And actually with, this has been discussed before, but with reference counting and the garbage collector as a scavenger kind of beneath it, I think it's a very good cohabitation solution. It's fantastic. It's gonna lift cycles when needed. It's just gonna work from under you whenever reference counting fails to pick the slack. And I think it would be a very powerful solution. And for that kind of collection, I think we have approaching a territory where we don't need to be very worried about that anymore. I do think that the next big one is the reference counting, and once we have the reference counting going, we can analyze like for the remaining class of problems and remaining workloads and remaining tasks and remaining whatever. Let's see how much garbage is there to collect. Right, so you're gonna have a list of garbage collection mafia to deal with. You know the documentary, right? Garbage collection mafia. Like there's a mafia that controls that kind of stuff in some countries, right? That should not be mentioned.
Ooh, is this a comment or a question? Question.
So there's one or two. We can take two more.
Two more. All right.
What are the plans for proto-object?
There's going to be a talk by Edward on it. The plans are we have a path, and just to make sure, like just to explain to everybody who may not have been in the loop, we have this object class, root of all classes, and it has these primitives that have been defined before. We added the qualifiers and the attributes and functions and whatnot, and therefore they are out of place in in a modern code base, because const doesn't work with you need two mutable objects to compare for equality, which is ridiculous. String to string produces like garbage. You can't write it without making garbage, and that has been a huge hurdle in adopting the, like for example, Sociomantic, they've had huge issues with it. And the solution we're working on right now is, well, how about this? So object has two roles. It's the root of all classes, and it's also the default root if you don't specify any. But how about we separate the two aspects, because you could have something that's default when you don't specify any, and there could be a different class which is the root of all classes. At this point, there's like an ahs and ohs from the audience, like, oh my God, so awesome, such a cool thing. All right, humility is a problem in this with me. So essentially, I think that was a very effective way to break the Gordian knot, which was, well, if you don't specify base, the base is going to be object, thus keeping backwards compatibility with all the existing code. But if you do specify base class, you have the option of specifying a different class, which is the root of all objects, which is the root of object, which of course there's got to be an object, which we call the proto-object. So you see the, right? I thought of arche object, but it just doesn't roll off the tongue, right? So proto object is better than arche object. Arche object. Okay, well, maybe we'll vote on it if you guys. What? Better proposals?
Sorry, were you done?
Maybe we'll have thing, which is like the, you know, the base of object. So anyway, so proto object would be the root of all objects. It would have, you know, we get to do it right because now the language is stable and we have the qualifiers and we have the attributes and we have the good things. And now we get to say, well, what is a good object? And Edward is working on that. He's going to give a talk tomorrow. I think there's Manu. I think.
Yeah, Manu's got a question, and if you're fine with that one more.
Yeah.
Right. Sorry, here.
Okay. So, one thing that was missing from your top 3 lists, but has been a rock-hard blocker for me and my kind since as long as I've been around, is workflow-related stuff, IDE integration, things like autocomplete. How do we motivate more people in the community to care about this problem? How do we get Rainer more support?
Oh, that was the end of the question.
That's a question.
You should say question mark.
I felt there, yeah. It felt implied.
I think this is a difficult topic. And I was expecting you're going to open with that. It is important, and I think we are often sort of interpolated in a forum that, you know, why don't you work on this? And that kind of stuff. And, you know, you can't work on what you're not good at. I mean, you can, but you're not going to be good at it. So Walter and I are just not good at that kind of stuff. Others are, they don't have the time. So, you know, as I often exhort, we need the product of talent and time, because much talent times a little time is like flash, right? And, you know, they say, like, if you could power with the thunderstorm, right? A thunderstorm could power New York for 5 minutes, right? Yeah, but that's actually what it does is it's gonna kill 2 cows. It's gonna burn 3 trees out there, right? It's not gonna light up any city or anything, right? It's not gonna do anything good. So we do have these flashes of productivity and stuff from people in the community, which reveal great talent, but not the product of talent and time. And that's where the energy comes from, is the product of talent and time. We did not unleash that. I think Mike has had a great initiative. Actually, Seb has had a great initiative, which Mike took and run with these Human Resources Fund, and actually making it easier for people to make donations of money, just to, you know, to provide a good incentive and social recognition to people who work on this kind of stuff. And I think this is going to continue, it's going to grow, and we're kind of discussing and talking and essentially like cajoling corporate sponsors to actually say, well, you know, if you want this feature and that feature, maybe we'll establish some fund for it that you can contribute to. So what we can do on our side is probably money, and that's it's not everything you need, but I think it's a very robust incentive.
Okay.
There's one more.
Andrei, during your talk on last DConf, you talked about that it might be a good idea to have like a unified interface to do introspection and a standard interface. I know that some people have been starting to write introspection libraries, but like, has there been any unified progress towards that?
There has not been a unified progress. I was actually emailing Walter and a couple of others about this, and so there's this post on the forum that started as a despondent. I give up, and I tried to do this introspection library, and I failed because of obscure issues. And then Attila came and said, "Well, wait a second. Actually, everything you say can't be done. I've done it, and it's right here in this GitHub whatever repository." And that was very interesting, I thought. And the thread kind of ended. It ended with, my understanding is, a solution to every problem that contributor had. Not to say, maybe not a solution, maybe at least a workaround. So I think there is some progress, but it's kind of informal and it's not very organized at the moment. I personally didn't make any progress on that, but I do think that's an important topic in the okay. I said like top 3 things in D. All right, number 0. All right, is introspection, because I didn't mention it because in a way it was like this. There's a radio show in LA, it doesn't matter, but essentially there's this guy who's like top 1 in the nation. It was the best radio show in the nation, okay? By far, right? There's a top radio show. And they had these callers calling, and this guy would tell them things, and this kind of, it was fun, right? So at some point, the caller calls and he calls and says, well, love your show, big fan, but, I think you should do better. And this guy didn't even listen. When I found it like, it kind of not humble, and I didn't like it, but it was very funny. It was revealing. He interrupted the guy. He said, I don't care. We're number 1 in the nation by far. You're not going to give me advice on what to do better. So that kind of, he berated that guy. And actually, I think part of the quality of the show was that this guy was like a complete jerk. Like, he was like a really, really unkind person. Like, he completely destroyed that caller for trying to pass him advice on how to do a better show than number 1 in the world, right? In the nation. So anyway, so to kind of paraphrase that anecdote, I think we're already miles ahead from any competition in terms of doing introspection and generic and meta programming and kind of all of this code generation stuff and all of these great things. That it's not a top issue for now because we're not behind. You see my drift here? So we're not kind of desperately trying to kind of get where we need to be. We're already kind of at a comfortable competitional advantage with introspection. So in a way, it's good to, of course, it's good to kind of stay ahead of the competition and kind of do a lot better because there's so much opportunity and so rich lands there to be grasped, right? But at the same time, it's not critical as reference counting or whatnot, right? So I do think progress in that area is being done. I think it will continue to be done, and I think Edward has, his research topic is introspection, and I believe that good things are going to continue to come in that area. And whenever, again, I'm very sensitive to the sentence, I cannot do what I want to do. I mentioned this last night. There's a talk at Symmetry. So this is like a big one for Walter and I. When people come and say, I can't do what I want to do. That's a biggie. It would be nice. It's a bad conversation starter for us, okay? If you come with it would be nice. We're kind of already looking at the door there. But if you come with, I need to do this and I can't do it, that's a biggie, right? So that's already, we come like, wait a second, what's going on here, right? So if anybody wants to do introspection, there are things they can't do, that's a biggie. And we should be we definitely are on top of that. So that sounds like a great question to end.
Yes. Yeah, all right, so we have finished up with the questions. Give it up for Walter and Andrei.
Thank you, folks.